Assalamualaikum dan salam sejahtera. Nama saya Nun binti Muhammad Nur. Anda boleh panggil saya Madam Nun. Dalam video kali ini, saya akan membincangkan penyelesaian soalan untuk ujian selaras 2 mata pelajaran fizik SP015. For question number 1, we want to determine the dimension of the Young modulus. So first step, you need to write down the equation for the Young modulus, which is stress over strain, and then write down the dimension equation, substitute the value, and then you will get the answer, which is ml minus 1 t minus 2. Please take note that for the strain, why the dimension is equal to 1? Because of strain is the physics quantity with no unit. Another way to solve this question is we use the derived equation for the Young modulus, which is FL over AE. We substitute the dimension for F, L, A and E, so you will get the same answer. For question number 2A, a ball is thrown vertically downward with an initial velocity of 5 meter per second from 20 meter height. So referring to the given information, U initial velocity and the displacement is negative because of both the direction is downward. So to calculate the velocity of the ball, before it reaches the ground, we use the equation of v square, which is equal to u square minus 2gs. We substitute the value and we get the magnitude of the velocity is 20.4 meter per second. And the direction is downward. For question number 2b, an object is thrown horizontally from the edge of a table with an initial velocity of 3 meter per second. If the height of the table 2 meter, calculate the final velocity of the object before it reaches the floor and also the horizontal displacement of the object. So referring to the information given, hidden information is Ux is always equal to Vx for the projectile motion, and at the maximum height, Uy is equal to 0 for the object which is thrown downward. So Sy, the displacement is negative. Okay, first we want to calculate the final velocity before it reaches the floor. To calculate the final velocity, we need to have the value for Vx and also Vy. So we know that Vx is equal to 3 meter per second. So now we need to calculate the Vy first. So we can use the equation of Vy square, which is equal to Uy square minus 2gs. We substitute the value and we will get the Vy. Then we can calculate the final velocity, which is equal to 6.94 meter per second. For the horizontal displacement of the object, the equation is Sx, which is equal to Uxt. We have no value for t, so we need to calculate first. We will use the equation of Sy, which is equal to Uyt minus half gt square. We get the t, which is equal to 0.64 seconds. Substitute in the equation and you will get the displacement, horizontal displacement, which is equal to 1.92 meter. For question number 3, a fisherman on a stationary boat jumps off onto a jetty with a velocity of 1.5 meter per second, causing the boat to move backward. If the mass of the fisherman and boat are 65 kg and 450 kg, determine the velocity of the boat. So first, to calculate the velocity of the boat, we will use the principle of conservation of linear momentum, which is sum of initial momentum is equal to sum of the final momentum. We substitute the value inside the equation and then we will get the answer, which is equal to negative 0.217 meter per second. So the value for the velocity of the boat negative because of the boat is moved in the opposite direction. For question number 3b, if the fisherman feet are in contact with the jetty for 10 milliseconds, determine the magnitude of the average force exerted on his feet. So to solve this question, to calculate the average force, we will use the impulse momentum theorem, which is J is equal to change of momentum. And we know that the impulse is also equal to Ft. So when we substitute in the equation, we can get the magnitude of the average force, which is equal to 9,750 Newton. For question number 4, referring to the figure 1 and the question given, we need to sketch the free body diagram. So the free body diagram consists of R, which is normal force acting perpendicular to the surface, F, which is friction force acting opposite direction of motion, the horizontal force F, and the weight which is exerted downward. To calculate the acceleration of the object, referring to the given information, we use the concept of Newton's law of motion. At the y component, sum of Fy is equal to 0, and at the x component, the sum of Fx is equal to ma, because of the object is accelerate with the acceleration a. So when we substitute in the equation, we will get the acceleration of the object is equal to 11.49 meter per second minus 2. Question number 5a. Figure 2 shows the graph of force against displacement F. From the graph, we need to determine the kinetic energy of an object at s is equal to 10 meter. To calculate the kinetic energy, first we will use the work energy theorem. To calculate the work done on the object, it is represented by the area under the graph and it is equal to 32.5 joule. When we substitute in the work energy theorem, we will get the final kinetic energy or the kinetic energy of an object at s is equal to 10 meter, which is equal to 132.5 joule. Referring to the figure 3, we need to calculate the speed of the object before it strikes the spring, and also we need to determine the maximum compression of the spring. So, if you refer to the solution, we will use the conservation of energy to calculate the speed, where the potential energy of an object is equal to the kinetic energy before it strikes the spring. From the calculation, we get the speed which is equal to 2.43 meter per second. And for the maximum compression, we will use the concept of kinetic energy, which is equal to the potential energy of the spring, which is equal to half kx square. We substitute in the equation and we get the x, which is equal to 0.768 meter. For question number 6, a 900 kilogram car moving at 10 meter per second take a turn around a circle with a radius of 25 meter. We need to determine the period of motion of the car and the net force acting on the car. To calculate the period of motion, we will use the equation of 2 pi r over v. The derivation is as shown. When we substitute, we get the period which is equal to 15.71 seconds. For the net force acting on the car, net force is equal to centripetal force, where the centripetal force is equal to mv square over r. When we substitute the value, we get the net force is equal to 3600 Newton. For question number 7, a rocket of mass 2.5 times 10 power of 4 kg is traveling from Earth to the Moon. The mass of the Earth and the Moon, the radius of the Earth, and also the distance of the rocket from the surface of the Earth is as given. We need to calculate the gravitational force, gravitational field strength, and escape velocity of the rocket. First, when we want to calculate the gravitational force, we need to calculate the distance of the rocket from the Earth, from the center of the Earth, which is the value is equal to 1 times 10 power of 9 meter. When we substitute in the gravitational force equation, we get the gravitational force which is equal to 10.005 Newton. For question number 6b, to calculate the gravitational field strength, we refer to the equation of gm over r square. We substitute the value and we get the answer which is equal to 4.002 times 10 power of negative 4 meter ms minus 2. For the escape velocity, we use the escape velocity equation which is 2gme over re. When we substitute, we get the answer which is equal to 11.21 times 10 power of 3 meter per second. Question number 8 is related to the simple harmonic motion chapter. We need to calculate the velocity and the acceleration of the mass that move in the simple harmonic. First, when we want to calculate the velocity, we need to find the angular velocity first by using the equation of 2 pi f. And then we substitute in the equation, we get the velocity of the mass which is equal to 43.53 cm per second. For the acceleration of the mass, we use the equation for the simple harmonic motion, A, which is equal to negative omega square x, and we get that the A is equal to negative 631.65 centimeter per second minus 2. For question number 8b, from the graph, we need to determine the angular frequency, the equation for the simple harmonic motion and also the total energy. To calculate the angular frequency, we use the equation of 2 pi over t. We get the angular frequency which is 0.5 pi radian per second. For the equation for the simple harmonic motion, we refer to the general equation first, which is x is equal to a sine omega t. We substitute the amplitude a and the angular frequency omega. So we get the equation for the simple harmonic motion, which is 5 sine 0.5 pi t, where x is in centimeter and t is in second. For the total energy, the equation is half m omega square a square. We substitute the value and we get the total energy, which is equal to 7.7 times 10 power of negative 5 joule. For question number 9a, the equation of progressive wave is as given. We need to determine the direction of the wave propagation, the wave speed, the particle velocity, and we need to sketch the displacement against distance graph. Okay, first, to identify the direction of the wave propagation, we refer to the sign negative. Negative shows that the wave is moved to the right. To calculate the wave speed, we use the equation of V is equal to F lambda. We get the F from omega over 2 pi and we get the lambda from 2 pi over k. When we substitute, we get the value which is equal to 2 meter per second. To calculate the particle velocity, first we need to differentiate the displacement equation to get the velocity equation. And then we substitute the x, which is equal to 2 meter, and t is equal to 0.1 second. So we get the particle velocity, which is equal to 23.3 meter per second. To sketch the graph of displacement against distance, first we need to substitute the value of t, which is equal to 0. When we substitute the value of t inside the equation, we get the equation which is equal y, which is equal to negative 6 sine 2 pi x. And we know that the lambda is equal to 1 meter. So the graph is the negative sign graph as shown. For question number 9b, two waves in a long string are given by equation y1 and y2. First, we need to write down an expression for the new wave or for the standing wave. So, general equation for the standing wave is 2a cos k x sin omega t. When we substitute the a, k and omega, we get the equation for the standing wave which is equal to 16 cos 2x sin 2 pi t, where y and x is in meter and t is in second. To calculate the three smallest value of t that correspond to antinode, we know that the antinode occur at the maximum displacement. So, 16 sin 2 pi t is equal to 16, which is maximum displacement. And when we calculate the t, we get that the t is equal to 0.25 second, 0.75 second, and the third one is 1.25 second. For question number 9c, a 50 cm closed pipe makes a sound when the wind blows across the open end. If the speed of sound is 340 meter per second, we need to calculate the second overtone of the pipe and the fundamental frequency of the pipe if the length of the pipe is half. So first, to calculate the second overtone, for the second overtone of the closed pipe, n is equal to 5. So when we substitute in the equation of the of frequency, we get the frequency for the second overtone, which is equal to 850 Hz. To calculate the fundamental frequency when the length of the pipe is half, so we just substitute L, which is equal to 0.25 meter. Then we get the fundamental frequency, which is equal to 340 Hz. For question number 9D, a fire engine is coming towards a station emitting siren at the frequency of 800 Hz. What is the possible frequency heard by a boy sitting in the station if the incoming fire engine is moving at 65 meters per second? So we will use the Doppler effect equation where the frequency heard by the boy is equal to V over V minus Vs times with the Fs. V minus Vs because of the direction of V is equal to the direction of Vs. When we substitute in the equation, we get the frequency heard by the boy, which is equal to 989 Hz. Referring to the question number 10, an aluminium wire with the diameter 1.5 mm is suspended from a rigid support with a load of 150 kg attached to its lower end. If the wire becomes 5.5 meter long, what is the initial length of the wire? The extension of the wire. So to calculate the initial length, we will use the Young modulus equation, which is equal to F L naught over AE. When we substitute, we get the L naught is equal to 5.435 meter. To calculate the extension of the wire, extension is equal to final length minus with initial length. When we substitute the initial length, we get that the extension of the wire is equal to 0.065 meter. For question 11a, two bars of the same diameter but different materials are joined end to end as shown. One end of the bar is at the 80 degrees Celsius and another end is 5 degrees Celsius. We need to determine the temperature at the interface if the length of the first bar is twice of the second bar. So first, to calculate the temperature at the interface, because of both bars is insulate, so it is in a steady state condition. So for the steady state, dq, the rate of heat transfer for in the first bar is equal to the rate of heat transfer in the second bar. So when we substitute the value, we get that the temperature at the interface is equal to 44.13 degrees Celsius. For question number 11b, a block of gold has dimension as given and at temperature of 30 degrees Celsius. If the temperature increased to 120 degrees Celsius, determine the change in the volume of the gold block. So, for question number 11b, it is related to the coefficient of volume expansion. So, we use the equation of delta V, which is equal to 3 alpha V naught delta T. When we substitute, we get the value for the change in the volume, 3.63 times 10 power of negative 7 meter cube. Question number 11a. A tank contains 1 meter cube of helium at a pressure of 1.3 times 10 power of 5 Pascal and temperature of 350 Kelvin. The temperature of the gas increased from 350 Kelvin to 370 Kelvin. What is the change in the internal energy of the gas? So, first we identify the hidden information, which is helium is monoatomic gas. So, the degree of freedom F is equal to 3. And to calculate the change in internal energy, we need to know the value for the mole of the helium gas. And we use the ideal gas equation, PV is equal to nRT. We get the N, which is equal to 45 moles. We substitute in the change in internal energy equation, we get the answer, which is equal to 1.12 times 10 power of 4 joule. For question number 12b, the RMS speed of hydrogen molecule at a particular temperature is 1330 meter per second. We need to calculate the RMS speed of nitrogen molecule at the same temperature. So to calculate, we use the RMS speed for hydrogen and nitrogen. We use the equation, we substitute the equation where 2 divided by 1 and we get the the RMS speed of nitrogen, which is equal to 355 meter per second. For question number 13, an ideal gas has undergoes two processes, AB, which is isobaric, and BC, which is isochoric, as shown in the figure. 400 joule of heat is dissipated from the gas in the process of BC. If the initial pressure and initial volume is given, we need to calculate the work done for AB and BC. So to calculate the work done from AB for the AB process, it is equal to P delta V. So when we substitute in the equation, we get the work done for AB is equal to 6000 joule. Work done for the BC is equal to 0 because of the volume is constant. Then we need to calculate the change in internal energy for BC. So to calculate the change in internal energy, we use the first law of thermodynamics, where Q is equal to W plus delta U. We substitute the value for Q and W. We get the change in internal energy, which is equal to negative 400 joule. Okay, that's it for the discussion of the Ujian Selaras 2. I hope that you can compare your answer with the correct answer. I wish you all the best for your PSPM and thank you.